The open shortest path first protocol has got very well designed approach in every manner, everything, every aspect. You will see a very good design for scalability areas. Because you got areas, you can do summarization on the borders. So if you notice here, we got networks starting with 8. I can do summarization on the border on R1. I can summarize all these 16 networks like 8.8.0.0/16 so that router 6 will not receive 16 subnets. Instead, it receives only one summarized update. Advantage is not much bandwidth for the update, not much process utilized to prepare the advertisement, as well as the receiving router no need to spend much time on processing the updates. Summarization is good. So all the routers to the left of router 1, like router 6, 5, 4, 3, they're all now going to have single route to reach those 16 subnets on area 500. So the routing table space is also now reduced. Summarization is good. And if you notice on R3, we have a RIP in the left, Ospf area 1000 in the right. Now when I take these 16 RIP routes and redistribute into Ospf, I'll be learning 16 external routes. Why do I call it as external? Because they don't belong to Ospf. Redistributed routes. External routes are notified in the routing table using E. If you see any route in the routing table, O, I, A, it means Ospf given routes, and it is inter-area routes. This is how you will see a route via router 5 after you do summarization on router 1. It is OIA. And when I do summarization here, 1.1.0.0/16, I'll see O, E2, 1.1.0.0/16 via router 3. The gateway, the IP address of router 3. E2 means external type 2. IA means inter area. What is the type 2? Type 1 and type 2 we'll discuss after a few minutes. Let us not mix everything now. What do we see here is Ospf can give you a very clear difference between the routes that is coming from other area, the routes that are coming from other autonomous system. EIGRP also does this, BGP also does this, but how they do it is they differentiate using the administrative distance. For eBGP it is 90, for IBGP it is 200. For external EIGRP routes it is 170. Routes coming from the same autonomous system of EIGRP it is 90. But you see how beautifully Ospf is designed. Ospf is not confusing you with different administrative distance. It says IA E2. Let's assume E2 is also advertising the same route what IA is giving. Which one it is going to prefer, IA. Going to RIP is not preferred. Going to OSPF's own network, it is in the other area, is preferred. See? If you ask in BGP, is eBGP preferred or IBGP preferred, you will say eBGP is preferred over IBGP. When there is tie in the attribute up to MED. Attribute 7 is eBGP preferred over IBGP. Here it is opposite. Why? Because it's an IGP protocol. OSPF is an IGP protocol, Interior Gateway Protocol. So it prefers route coming from same autonomous system, same OSPF, rather from other routing protocol. For which there is no administrative distance used, it is this marking IA E2. If you see simply O, it means same area. OSPF given route coming from same area. Same area coming from other area, coming from other protocol, other autonomous system. We can do summarization for both IA as well as E2. If you want to do summarization for IA, you need to do on the ABR. Which ABR? The ABR that belong to that area for which you want to do summarization. I want to do summarization for area 500 network, so I have to go to router 1 and summarize. And if you want to summarize the external networks, ASBR is the right place. What is this called as? ASBR. So today we are going to focus on these two type of summarization, ABR summarization and ASBR summarization, followed by E2 and E1. What does it mean? E2 and E1. Now first let's begin with the summarization. I'm bringing this router which runs RIP. Now if I'll go to router 3, On R3, if you notice, show IP route RIP, you can, sorry, show IP protocol. I have only Ospf running. There is no RIP. It's okay, let's run RIP now. Router RIP version 2, no to summary, network 23. That's it. Now I'm expecting show IP route RIP. Route RIP.
Sir, RIP, sir.
Yes, sir.
Router 2 தானே சார் பண்ணணும்?
Router 2 should have, according to me, router 2 is already configured. Router 3 also we have to configure so that router 3 can learn route from router 2. You have to do RIP configuration so that on this link, RIP will function, RIP will work. On this link, it is Ospf already. On this link, you have to run RIP, only then this RIP advertisement will be learnt on this router. Yes or no?
Yes, sir.
For that reason, I went to router 3. I don't know, router 2 may already have, but router 3 also needs the configuration, you see. Show run section router RIP. I enabled only on 23, only on this interface. Okay, so don't worry. I'm not running on the other interface. Now I'll go to router 2 and check the status. Router 2, show IP interface brief. Okay, it has got all those loopback interface. Show IP interface brief again. Is the physical interface up, but I'm seeing wrong IP address. So now, okay, here I'm seeing wrong IP address. What about router 3? Show IP interface brief. Okay, this is 10 dot. I'll change it. Interface F0/0, no chat. IP address is 23.0.0.3. And also on router 2, I'll remove that F00. On interface F01, 23.0.0.2. Now I'm expecting show IP protocol. No protocol. I'm going to run RIP. Router RIP. Networks are 23 and all beginning with 1. Okay. Now if I go to router 3, I must be learning the routes. Show IP route RIP. You see, we have learned all those RIP routes. And if I simply type show IP route, I will see RIP as well as Ospf. You see, IA, inter area. Fine. Now what is next? What I'm going to do is I'm going to redistribute the RIP routes into Ospf so that router 4 also may know about those external rip routes. Show IP route. As of now, you don't see the routes to go to 1111 network. You don't have any routes. Do you have any 111 network? Let me show you. Show IP route 101. Okay. 101. No routes. No routes. Whereas you can see the route in routing table of route 3. Show IP route. It says I learned from RIP. It's one hop count away. And this is the gateway address, and this is the interface via which I need to exit. Yep. Router 4 don't know about it, so router 8 also will not know about it. Show IP route. There is no route to reach 1111. Show IP route 1111. No routes. So definitely you cannot ping. What we are going to do is we are going to redistribute back to back, meaning I'm going to redistribute from RIP to OSPF and OSPF to RIP. First of all, I would like to go to router OSPF and say redistribute RIP. So I'm telling take all the RIP routes. Including the subnetted networks. You have to use the word subnet, only then the subnetted networks will be advertised. By default, OSPF will not advertise the RIP routes or any other routes that are subnetted. Use the keyword subnet to say OSPF include even the subnetted networks that are in RIP. Actually, we have all the networks subnetted only. You see here, all of these are subnetted. None of them are class full. Even the link between R2 and R3, you see that /16, 23/16. So now we have to use the word subnets. Because you said this, go to router 8 now and type show IP route 1111. You can see the route now. When you see the route, what you see here is a metric 20. What is this metric, from where it has come? See, when I redistribute, I did not say any metric. If you don't say any metric, OSPF will provide 20 as a default metric for all redistributed routes. Wake up. What is the default metric OSPF provides when you redistribute a network? When you redistribute routes from some other source, it is 20. Don't forget. And now I'm going to say metric maybe 100, just to teach you. I said 100. Now if you go back to router 8, earlier it was 20, no? But now it is 100. When you don't say any metric, it is 20. We call this as seed metric. What is called seed metric? What is called seed metric? The metric that is given to the routes on the redistribution point. Wake up. The metric that is assigned to the routes by the redistribution router, where we did the router where we did the redistribution, is what called a seed metric. What is the metric I gave on R3? 100. Is R8 close to R3 or far away from R3? It is far away. But you see the metric is not growing. See, in between R3 and R8, how many routers, how many links are there? 1, 2, 3, 4, 5 links are there. If I give 100 in R3, I should say at least 105 if one cost per each link. If one is the cost for each link, at least I should say 105. But why the cost is not incremented? The metric that I gave on R3 remains same on R4, R5, R6, R7, R8. Why is that? The answer is, what is the use of adding all the metric in the path? Whether you add metric or you don't add metric, the only path you have is via router 3. Yeah. In case if you have multiple paths between router 3 and router 8. See, currently the only path to go to RIP route is only via router 3. To reach router 3, you will take router 1, 6, 5, 4. There is no other path to compare and say this is shorter than that. So there is no point of calculating the metric. Most of the time, this is what the scenario is. So Ospf is designed by default not to calculate the path cost. Whatever you give as a seed metric will be same on all the routers inside the autonomous system. The metric never grows. The seed never germinates. No one pours water to it. Poor seed. 100 remains the same. This is what called as E2. I told you, no? Show IP route. You see E2. What is the meaning of E2? The metric should not be incremented. The metric, whatever is given during the redistribution time, should be kept same for all hops. You may be going through various bandwidth links. The metric remains the same, unchanged.
Even sir, it cross the different autonomous system also, different area.
My volume is not clear. Can you repeat again? It's too loud.
Sir,
So try to reduce the voice and then ask me the question.
so I'm saying, sir, whether it's cross the other A's also, it's the same, other area.
Of course, it's the other area, no? Area 500. Router 8 is in which area? And router 3 is in which area?
Yeah, area 1000 and area 500.
Yeah. So there are many areas and many links and many routers. Even though it is many routers and many areas and many links, the metric given in R3 remains the same. Because by default, it is E2, meaning path cost not added, need not to be added. External type 2. Now what I'm going to do is I'm going to show you how to change it as type 1. I'm going to say metric type, you see, 1. 2 is default. What is 2? Path cost should not be added. What is 1? You add the path cost to this metric. I have given 100 as a metric. For each link, cost is 1. So when it reaches router 8, it should be 100 plus 5. Let me see. You see? 105. You see now? type 1. Earlier it was type 2. When you change type 1, the pathcast gets added to the seed metric. Let us change the seed metric. I remove this and I say seed metric as, let's say, I don't give any seed metric. What is the default seed metric? 20. Now 20 plus the pathcast is what? 5. So I should see 25. You see, 25. So if it is E1, the pathcast is going to be added. E2 means pathcast won't be added. Fine. Now let's get into the main topic, summarization. To show you how important is summarization, I would like to take router 6, which is in the middle, show IP route summary. This output shows how much of total memory in bytes the routing table is consuming. As of now, the routing table is consuming 11,667 bytes, in which external type 1 routes are 18 routes. Internal are 23 routes inter-area. When you do summarization, this 18 will become 1. Even in this 23, there is 18 routes coming from area 500. So I can also, this can also be reduced to like 5 instead of 23. When you reduce the number of routes, the memory consumed will be less. Not only the routing table is going to be less small, the bandwidth the memory that is consumed will be less. You see, show IP route. Right now it is going many pages, and the size of the routing table is 1167. I'm going to show you how to do summarization for ASBR first. Where is the ASBR? Which router is ASBR? Which router is ASBR? Router?
R5.
R3.
Router 3. So I'll go to router 3 where we did the redistribution. And I say router Ospf 1 summary address command. Please make a note. There will be a big difference between ASBR summarization command and ABR summarization command. See, ASBR is between some other protocol and Ospf. So there is no area involved in other protocol. RIP don't have any area. So there won't be any area mentioned in this command, summarization command. Whereas when I do ABR summarization, there is going to be an area involved because I'm going to summarize the network of area 500 on R1. So there will be area in the command when you do summarization. So ASBR summarization syntax is this: summary address. How do you want to summarize? I want to summarize 1.mask255. Boom. So router 3 is going to see any network starting with 1 will be summarized to 1.000/8. If you go now to router 6. Earlier we saw lot of E1, but now I see only one E1. Okay, another one here. 23 network. So we have done summarization for all the external network that begins with 1. And check the size of the routing table. Earlier it was like 11,000, but now it is 8,408. Sorry, 8,048. The external routes were 19 earlier. It is now 2. It is now only 2. Next. I'm going to do summarization for these networks that are coming from area 500 on R1. I'm in R1, router OSPF1, area 500, range, listen, range, not summary address, range. I'm saying area 500, range, which network? Match this network. That's it. Area 500, range. This is the syntax to summarize the networks of an area on the ABR. Now if you go back to router 6, earlier when I was showing, there were many IA with 8 network, but now there is only one IA with 8 network. And the routing table has also now reduced to less than a page. Earlier it was like 2-3 pages. And check the size of the routing table. It is 4,000. Early in the beginning it was 11,000. Came down to 8,000. Now it is 4,000. See, in a small demo topology like this, if you can have this big difference, how big capacity impact you will find if you do it in the real world. Summarization is good. Yeah, we have learned how to do summarization, both ABR and ASBR. Can I ping using the summary address? You can ping very well. But for that, R2 also should know to reach OSPF. So what I'll do, R2 is running RIP. So I'll go to R3 and take OSPF route and give it to RIP. Router RIP. We have given RIP to OSPF, but not from OSPF to RIP. So we have to say router RIP. Let me show you once before I do that. Show IP route. You see, there is no route coming from OSPF. You got only the locally connected networks. No routes are learned from OSPF. Now we are going to redistribute OSPF1 metric. You have to give metric, some metric for RIP. The metric is hop count, so I'm going to simply say 6 is the hop count for all the OSPF routes. Now if I'll go to router 2, I'll be learning, you see, a lot of routes. So you got a summary route because we have done summarization on R1. Arindaram, this was a partial question that you asked. Not only to other areas the summary route will go, even to the other autonomous system it will go.
Yeah.
Now from R2 I can ping 8.8.15.1 8.8.15.1 with a source of Lubeck here is 1.1.15.1. See, we are able to ping back to back. If you want to trace route, you can trace route and see. Though we don't have a detailed route, we will be able to ping. And now, if you go back to router 8 and try pinging, right now you don't have a detailed route. See, show IP route, do you have 1.1.15.1? You don't have, you got only a 1.1.15.1 show IP. Yeah, it says that it is using this summary entry to reach this. So if I now trace route 1.1.15 or 14.1 goes to router 2. Yep, summarization both ABR and ASBR is done. Let me quickly show you what we did. On ABR, the syntax that we used is range, because OSPF knows range very well, sorry, area very well, and the network is coming from an area called 500. 500. So we say any network coming from area 500 need to summarize like this. But the RIP networks, they don't know area. So when you do summarization, the command is summary address. This is what called as ASBR summarization. So we have learned now ABR summarization, ASBR summarization, E1, E2, IA, see, show IP route OSPF. IA means what? Coming from other area. You see 10.16 is between router 6 and 1 from area 0. Whereas this 4.4.4.4 is in the same area, that's why you just got O. I mean R3. You see? So we can see here OSPF has got a very good, nice approach in all OSPF features. Now, let us go and do some fine-tuned summarization. Listen, I would like to summarize only these three networks. I do not want to summarize all these. I want these to go detail, only these three to be summarized. Can we do it? Yes, you can do it. How? Let's see how. Before that, I want to show you once R6 show IP route OSPF. You can see you got 10000. Now what I'm saying is I should see summary only for this first three and all the rest should not be summarized. How can we do it? Go to R3 and router OSPF1. I remove that early summarization that we see. This is the command. I remove it and I say now summary address 1.1 is okay, 0.0 255.255. So these two octets should match, followed by on the third octet I want the summarization only for three networks. So simply put 4 is not 3.0. Okay. 255 minus 3 is 252. Yeah, like this. 252.0. So now if you will go and check on R6, you see up to 3 is summarized, all the rest are not summarized. Now I'm going to show you, I want to summarize only up to 7 in this. All the rest I do not want to summarize. How can we do that? I'll do it on R1. On R1, I will remove that range command, blah, blah, blah. And I'll say now area 500, range 8.8 dot. I want to summarize up to 7. 0.0255.255.255 minus 7 is 248. That's it. Now if you go to router 6, we are talking about IA. You see, first 7 is summarized. From 8 onwards, it is not summarized. That's all about summarization.